Alright, so this is what we were talking about. Valence electrons are electrons in the outermost energy level. This makes them special because it's only these electrons that can participate in reactions. And as organic chemists, we're interested in reactions, how one atom reacts with another atom. And the way that these atoms react is by using their valence electrons, their outermost electrons. So really, organic chemists are only interested in these outermost valence electrons. And this brought about something called Lewis structures. Okay, so for a while, organic chemists were visualizing valence electrons by drawing out the entire structure of an atom and then putting a box around those valence electrons, or they were drawing out the electron configuration, 1s2, 2s2, 2p2, and then just putting a box around the valence electrons. Okay, so organic chemists are interested in visualizing valence electrons. These were the two ways that we had to do it before, until Lewis came along with something called Lewis structures. He's like, why waste our time drawing out this entire structure of an atom, drawing out this entire electron configuration if all we're concerned with is these valence electrons? Let me give you a better way. Okay, so what he said was, go ahead and just draw the symbol for the atom. In this case, we're talking about carbon, so let's do C for carbon. And he said that on the four sides of this symbol, we can just draw one dot per electron. Okay, so let me show you what I'm talking about. Carbon has how many valence electrons here? Well, 2 in the s orbital, 2 in the p orbital, giving us a total of 4 valence electrons. So Lewis says, draw out the symbol of the atom, and for each of the valence electrons, give them one dot. Okay, so 4 valence electrons, that means you'll have one dot per valence electron. That's 1, that's 2, that's 3, that's 4. Okay, so what this is saying is that carbon has 1, 2, 3, 4 valence electrons. This is a shortcut for drawing out this whole thing. Okay, let me give you another example so you can understand what I'm talking about. Okay, so let's take, for example, nitrogen. So draw the symbol for nitrogen, which is N. Okay, and nitrogen, his electron configuration would be 1s2, 2s2, 2p3. Okay, so we're concerned with the valence electrons. How many valence electrons does nitrogen have? Well, 2 in the s orbital and 3 in the p orbitals, so giving us a total of 5 valence electrons. Lewis says give one dot per valence electron. So give one here, one here, one here, one here, and then once you're back to the top, then just start giving an extra dot, okay? So nitrogen has a total of 5 valence electrons, so you see 1, 2, 3, 4, 5 dots around that symbol. Carbon had a total of 4 valence electrons, so you see 1, 2, 3, 4 dots around that symbol. And this gave us a really simple way of visualizing how many valence electrons an atom had. So instead of having to draw this entire structure of this atom or the electron configuration for the atom, now all we have to do is just draw out the symbol for the atom and then one dot per valence electron, okay? Alright, so just to make sure you have this Lewis structure concept down, then why don't you go ahead and tell me what the Lewis structure for oxygen would look like. Okay, so I'll help you out and I'll tell you that oxygen has the electron configuration of 1s2, 2s2, 2p4. Okay, so go ahead and take a second and draw out the Lewis structure for oxygen with this electron configuration. Alright, so remember, Lewis structures, all we're concerned with is how many valence electrons that atom has. Okay, so we're talking about oxygen here. So the symbol for oxygen is an O. Okay, so how many valence electrons does oxygen have? Well, 2 in the s orbital and 4 in the p orbital, giving us a total of 6 valence electrons. So go ahead and just start at the top and one dot per electron. Okay, so 1, 2, 3, 4. Oh, we're back at the top, so add another one here. 5 and 6. 1, 2, 3, 4, 5, 6 valence electrons. That matches the 6 valence electrons we were talking about up here. So this is the Lewis structure for oxygen, okay? Alright, so I've got one more thing here to say about Lewis structures, and I've left nitrogen up here as an example for us. What I want you guys to do is take this diagram that we drew for a carbon atom, and I want you guys to change this so that it represents a diagram for a nitrogen atom now. Remember, nitrogen has one more electron than carbon did. Carbon had 6 electrons with the electron configuration of 1s2, 2s2, 2p2. Nitrogen has 7 electrons with the electron configuration 1s2, 2s2, 2p3. That's where the extra electron comes in for nitrogen. Okay, so what I want you guys to do is fill in where this extra electron goes in this diagram. Then we'll come back and talk some more about Lewis structures. Alright, so all we had to do to change this to a diagram of a nitrogen atom was just add in the one extra electron that nitrogen has, right? So we added that extra electron, put a box around that one to show that, hey, he's a valence electron too. He's one of the outermost electrons along with the rest of these guys. And this is exactly what our Lewis structure is telling us. Our Lewis structure is telling us that nitrogen has 1, 2, 3, 4, 5 valence electrons, just like this is telling us that nitrogen has 1, 2, 3, 4, 5 valence electrons. Okay, so all a Lewis structure is just a shortcut for drawing out this big thing, okay? Alright, so I think you guys understand how to draw Lewis structures pretty good now. But some of you might be wondering, well, why do we draw it this way? Why do we draw it with the symbol for the atom in the middle and then the valence electrons on the 4 sides of this thing? Like, why don't we just put all the valence electrons right next to each other? Well, a couple reasons. Number one is because it's easier to look at that way and count how many electrons we have. And the second reason is because of the octet rule. Okay, so if you guys remember the octet rule from GChem, this said that all atoms want 8 valence electrons. Another way of saying this is that all atoms are most stable with 8 valence electrons. Another way of thinking about this is that when you look at the structure of an atom, if you look at its outermost orbitals, okay, so these are the outermost orbitals that the valence electrons are in, the octet rule says that all atoms are most stable when all of these orbitals are completely filled. And by completely filled, I mean 2 electrons per orbital. So if you take a look at this thing, you can see that there's 2 electrons in this orbital, so he's completely filled. But in each one of these orbitals, they only have 1 electron each. They each need 1 more electron to become completely filled. Okay, so this is exactly what Lewis of the Lewis structures was trying to demonstrate. He was saying that each side of this atom stands for one of these orbitals. Okay, so if you want to, you can even draw in a rectangular box to represent that that's an orbital, that's an orbital, that's an orbital, and that's an orbital. And this is exactly what we're seeing over here. Okay, so if you see this orbital with 2 electrons is this orbital with 2 electrons. And then you can see this orbital, and this orbital each have 1 electron in them. Just like this orbital, and this orbital each have 1 electron in them. Alright, so the octet rule is saying that all atoms, well, not really all atoms, you guys, there are exceptions, but most atoms want 8 valence electrons to be the most stable. Okay, so they're going to want 2 electrons in each one of these orbitals to have a total of 2, 4, 6, 8 valence electrons to be the most stable. Okay, but where is nitrogen going to get another electron for each one of those orbitals? Well, electrons aren't just flying around in the air, right, you guys? Electrons are connected to atoms. So the way that this nitrogen can get other electrons for each one of these orbitals is by having an atom come and share electrons with this orbital. Another atom can share an electron with this orbital. Another atom can share an electron with that orbital. And what is it called when 2 atoms share electrons with one another? That's called a bond. So the way that this nitrogen can get other electrons to fill these orbitals is by bonding with other atoms. And this is exactly why Lewis drew out a Lewis structure this way. So we can see exactly which orbitals need more electrons, and so that tells us how many bonds nitrogen wants to make. Nitrogen has 3 orbitals that only have 1 electron in them, so it's going to want to make 1 bond at each one of those places, okay? Alright, so here's a quick demonstration to illustrate what I'm talking about. Okay, so if you took a hydrogen atom and a nitrogen atom and you stuck them in the same room together, what do you think is going to happen? Well, let's look at the situation. We've got a nitrogen atom with 3 orbitals with only 1 electron in each one of those orbitals. In order for nitrogen to be the most stable it can be, it's going to want to add 1 more electron to each one of those orbitals. A similar situation is going on with hydrogen. It's only got 1 orbital and 1 electron in that orbital. So hydrogen, in order for it to be the most stable it can be, wants to fill up that orbital with 2 electrons. So if this hydrogen and this nitrogen, they see each other, then this hydrogen is going to say, hey, I've only got 1 electron in my orbital. I want another one. Nitrogen is going to say, hey, I only have 1 electron in this orbital. I want another one. Why don't we go ahead and come together and share our electrons in a common orbital, also known as a bond? Okay, so hydrogen and nitrogen, they're going to say, why don't we come together, share our electrons, and form a bond? And it's going to either be illustrated like that, or you can draw it out like this, where hydrogen is now bonded to nitrogen. This line represents 2 electrons being shared in a common orbital known as a bond, okay? Alright, so the octet rule is saying that all atoms want 8 valence electrons to be the most stable. Well, almost all atoms, right? You guys, there are exceptions. Take hydrogen, for example. It's only got 1 orbital, so it only wants 2 valence electrons. But most atoms, like nitrogen, want 8 valence electrons. And if those atoms don't have 8 valence electrons, the only way that they can get more is by bonding with another atom. Like we saw here with hydrogen bonding with nitrogen. That filled up one of nitrogen's orbitals, but nitrogen still has 2 other orbitals that need electrons in them. And the way that they're going to get that is by bonding with other atoms, okay? So that was the octet rule. It's just saying that almost all atoms want 8 valence electrons. Let's go ahead and write a couple more things down here about the octet rule now. Alright, so these are just some things to keep in mind when you're talking about the octet rule. Okay, so the octet rule says that all atoms want 8 valence electrons so that they can fill up their outermost orbitals with 2 electrons in each orbital. That way they can be the most stable they can be. If an atom doesn't start out with 8 valence electrons, then the only way it can get more is by bonding with other atoms, by getting other atoms to share their electrons with it, okay? And that's what we saw in our demo a minute ago with hydrogen and nitrogen. So I put an asterisk next to all because there's exceptions to everything, you guys, and I've listed these exceptions up here. And you don't need to memorize these, just have these in the back of your mind if you happen to see an atom that has a weird number of bonds to it. Okay, so hydrogen we saw a second ago, it only wants 2 electrons because it's only got that 1 orbital. Okay, second exception is atoms in columns 3A like boron. And the third exception is atoms in period 3 like sulfur. Okay, so just keep these in the back of your head. If you happen to see them on paper and it looks kind of funny that like, hey, these things are violating the octet rule, remember there are exceptions to the octet rule, okay? And awesome, you guys. Now we can move on to the last part of today's session. We started out today by talking about how compounds are atoms stuck together by some type of glue. And that glue comes in the form of what? Electrons, right? Electrons interacting between 2 atoms. And depending on the type of interaction of those electrons, you can have 2 different types of bonds. You can have electron taking that'll form an ionic bond, or you can have electron sharing, which forms a covalent bond. Okay, so let me go ahead and erase all this, and we can talk more about these 2 different types of bonds we can have.